All right. Good morning, everyone. We're going to work on 3.4. Next Monday is your exam. Well, you will get 1 day. Last time you got a little extra because of 4th of July. A couple of people wanted an extension. So I gave it to the whole class. You're going to get 1 day. I'm working on your study guide. Basically, wherever we leave off tomorrow, that'll be the cutoff point for exam 3. All exams will be cumulative. So keep that in mind. So the good news about 3.4, and you can interrupt me anytime if you have any questions for me. The good news is this section is basically a review of what we have done in the past. These are the basic definitions of tan. Excuse me, guys. Okay, so we know what sine and cotangent are. Okay, sine is tangent is sine over cosine, cotangent is cosine over sine, and we know the reciprocals. Okay. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the reciprocal of tangent. And these are called Pythagorean identities. Sometimes I use the word trig identities, both are acceptable. Okay. Now, this part is the last part is the one we generally struggle with. So I'm going to go over it again. It was explained in chapter 2, but I'm going to tell you why these formulas, these are called even odd identities, why they look the way they do. So here's a unit circle. Suppose this is my unit circle. Okay. Really, you have to understand two things. Why cosine, if this is theta, and if this is minus theta, are going to be the same because cosine is the x coordinate. These 2 points will have the same x coordinate. So if somebody asks you to find cosine theta, you can safely say cosine negative theta. If somebody says find cosine negative theta, you can safely say it's going to be cosine positive theta. That's all they're saying here. Okay. Sine theta. How does that work for sine theta? It doesn't work that way. Okay. I'll show you. It doesn't work that way. So here, this is, let's say, positive theta, and this is, let's say, negative theta. Okay. And this is negative theta. What's the relationship between negative theta and positive theta? This is, let's say, negative theta, and this is positive theta. All right. The relationship is, it doesn't matter where you draw the line, guys. One is the sine is the y coordinate. It's going to be different sign. If this is +2, if this is plus half, this is going to be minus half. It's going to be flipped, right? So that's what they are really saying. Sine negative theta is negative sine theta. If you know these two, if you know these two, if you know these two, you can easily say cosecant is same as sine because they're reciprocals. And secant is same as cosine because they're reciprocal, same rules. Now, tangent works this way. I'll show you the one for tangent. You can do the work for cotangent. You can prove the one for cotangent. So let's say I want to know what tangent minus theta is. Negative theta is. Is it negative tan theta or it's something else? We'll figure it out. So instead of tan negative theta, I'm going to write sine negative theta divided by cosine negative theta. Why? Because that's how tangent is defined. But what did we do right here? Instead of sine negative theta, I'm going to pull out the minus sign because that's what the formula says. And cosine, for cosine, I'm just going to ignore the negative sign. And what do I get? Sine theta over cosine theta is tan theta. And don't forget the minus sign. And you can prove it exactly the same way. Cotangent theta, cotangent minus theta is minus cotangent theta. And the way, of course, you can have it in front of you when you take the exam. The way I remember it, I know that cotangent and cosine and secant, you can basically ignore the minus sign. For the other four, the minus sign comes out. And the explanation is here. I'll give you a little bit of time to see if you have any questions for what I just did. All right. So other than that, guys, we're ready to move on. I'll show you something here that will be used. This is really algebra. If you do FOIL, I'm going to show you the first one. You can do the other two exactly the same way. The first one is a plus b squared. That simply means a plus b times a plus b. And if we FOIL it, remember FOIL is the first term. If you multiply a and a, you're going to get a squared. And then the middle term, a and b, then the outside terms, FOIL, then the inside terms and the outside term. Doesn't matter which one you write first, really. And then the last terms, which will be b squared. And a plus b, a times b, there are two, so we can write 2 here. So here is how the first formula can be explained, okay? And you can do the same foiling with a minus b times a minus b. You're going to get something like this if you do it right. And these formulas are not in your book, so you want to write it down somewhere handy. And the last one is very easy. I'll do the last one for you guys. Same foiling. A minus plus b, a plus b, a minus b. And a times a is a squared. And FOIL, outside term plus a minus b is minus ab. Inside term plus a plus b is plus ab. And the last terms L minus b times plus b is minus b squared. Now, guess what? The middle two terms, they can be canceled because they're the same thing with opposite signs. Okay, so we're going to use these three basic algebraic formulas that you have learned probably in high school. Not probably, I know you have. So other than the formulas here, let's bring them on the same page. So we will use these formulas to solve a bunch of problems. That's the plan for today, 3.4. Okay, I'm going to save them here in case I have to refer to them, which I probably will have to. I think we can jump right in, guys. Read the top. Establish each identity. How do we establish identities, guys? We show that the left-hand side is equal to the right-hand side. So I decided I will do some of these problems. So let's see which ones we can do. I'm going to try the very first one, 21. So 21, I'm going to start with the left-hand side. Okay, the rule is, guys, you start with the left-hand side or the right-hand side, whichever is more complicated. If you can work your way and simplify it and so that it's same as the one on the right-hand side, you're good to go. So that's how I'm going to do it. I'm going to say the left-hand side is equal to cosecant theta times cosine theta. Now, my goal is to, excuse me, my goal is to show that that's same as the one on the right-hand side, cotangent theta. How do I do that? Well, one way to do it is see if you can convert everything to sine and cosine. Okay, so I have cosecant. Cosecant is the reciprocal of sine, so I can write this. And here I have cosine theta, didn't do anything with it. Okay, things are already looking much better because I have a cosine theta here. Cosine theta times 1 is cosine theta. And divided by sine theta is still there, didn't do anything with it. And clearly this is cotangent theta. Why? Because that's the definition of cotangent theta, and that's equal to right-hand side. So there will be some problems where they'll show you in your packet and ask you to tell you which step is correct. So you want to know the steps. Okay. When you do by the end of our lesson today, you should be able to do the problems from 3.4. And some of the problems will be of that nature. They'll show you catch error, which one is wrong. So you have to know how to do it. So we just proved it. So this is for this. I don't have to check the answer in the back because this is a different kind of a problem. You start with one of the sides. I tend to start with the side that's more complicated and simplify my way to get to the one on the right-hand side. Sometimes both sides will be complicated, and we're going to simplify it and prove that they're really the same. Now, if you have any questions. All right. 22 is very similar. Let's try 23. And of course, you can pick your problem. That's not a bad one. Let's try it. It's worth our time. 23. All right. So again, I take the one that's difficult. I would say the left-hand side is difficult. So I'm going to start with the left-hand side. And I'm going to say that's 1 plus tan square theta. Now we just learned minus theta for tan can be pulled out. But when you square it, I'll show you. This can be pulled out. This can go here. But when you square something like this, the minus sign is when you square a minus sign, you lose it. You lose it. Okay. So you're going to lose the minus sign. And I am just going to simplify it and just write tan square theta. That was the explanation. Okay. I'm just going to write tan square theta. All right. Remember our trig identities? Our trig identities are very, very handy for this section. Let me see if I can go there. These are called trig identities. 1 plus tan square theta is secant square theta. I can use that fact, okay? And we proved it when we did chapter 2. So instead of 1 plus tan square theta, I can simply write secant square theta. And that's my right-hand side. I'm done. Proved it. That the left-hand side and the right-hand side are the same. Any questions, guys? Any questions from anyone? Okay, guys. No. What else did I want to do? I'm doing some of the easier ones first, okay? 25. Okay, that's a good one. That's a good one. 25. All right. So the left-hand side is, I'm going to leave the right-hand side there. The left-hand side is this. All right. Now, you can do these things differently, okay? There's not just one way you can do them. There are multiple ways you can do them. So I am going to write here, instead of tan, I'm going to write sine theta over cosine theta. Plus cotangent is cosine theta over sine theta. All right. Now, when I multiply or distribute, when I distribute this over, multiply these two, this will be gone, this will be gone. Okay. Let me think. Yeah, that's fine. I won't distribute yet, guys. I won't distribute yet. It'll work. Let's do it slightly differently. All right, so guys, I cannot do anything with the bottom because the denominators are different. But remember, guys, if I multiply this here by on the top and the bottom and take this, multiply it here and here, I'll have the same denominator and then I can add the fractions. Let me try that. Okay, let me try that. So what I'm going to do, is this. I am going to say, so I will leave cosine theta here. So sine theta times cosine theta. And if I multiply the bottom by sine theta, I'll get cosine theta times sine theta. And I had a sine theta here, so I'll get actually a sine squared theta. All right. If I multiply cosine squared theta by cosine squared theta here, I'm going to get a cosine squared theta on top. The denominator will be the same. And that's not bad. That's not bad, guys, because now I have the same denominator. If I have the same denominator, I can simply add the numerators. I can simply add the numerators. And that's exactly what I'm going to do. And whenever you see sine squared theta plus cosine squared theta, you know using this sine squared theta plus cosine squared theta is 1, using this identity, trig identity, you can always say this is 1. I'm just going to delete it because I need the room. This is 1. Now, you can cancel this cosine theta and this cosine theta, and what are you left with? You are left with cosecant theta, but we'll do a little bit of work. So if I cancel this cosine theta and this cosine theta, I'm left with 1 over sine theta. And that is cosecant theta because that's the reciprocal. And that is the right-hand side. And I just proved it. You had to do a little bit of work on this one. I'll let you kind of process it and think about it, whatever works for you, okay? Put it here. These are fun. So you want to follow the steps because I think there are some problems in the book that ask you to kind of identify the error or tell you to find the right one. All right, guys. 27 is what we're going to do. 27 is a little different. And you're going to see these are getting slightly difficult as we move forward. Okay? Just slightly. Let's try this one. All right. So, of course, the left-hand side is more complicated than the right-hand side. And I am going to start with the left-hand side because I want to simplify the left-hand side, the side that's more complicated. It really doesn't matter where you want to start. So instead of tan and cot, well, guess what? I know they're using u, okay? Doesn't matter. I'm going to use theta if you don't mind. Tan and cot will cancel each other. They're reciprocals of each other. So I can write 1 minus cosine square. I'll write u just to be consistent. Okay. 1 minus cosine square u is, let me see if I can get you a better. Not this one. Trig identities. Give me 1 second, guys. I'm going to bring some trig identities for us. Right, this one. This will help us a lot. So guys, these are the trig identities, okay? Now the blue ones are the ones we are more familiar with. Sine squared theta plus cosine squared theta is equal to 1. But if you subtract cosine squared theta from both sides, you get the orange version. If you subtract sine squared theta from both sides, you get this orange version. We are familiar with this blue one. Tan squared theta plus 1 is secant squared theta. But if you subtract 1 from both sides, you get the orange one. Same kind of a story. Cotangent squared theta plus 1 is equal to cosecant squared theta. But if you subtract 1 from both sides, you get this orange versions. So you kind of want to be familiar with all of them. And 1 minus cosine squared theta right here, from the first orange one, I can write is equal to sine squared theta. I'm just going to write u. Okay. And this is the right-hand side. Done. Any questions from anyone? Now, these problems are short, so I'm going to do one more before we go to the next slide, next session. So 27, let's do 30. Let's see, oh, 30 is good. It's one of the harder ones. Wonderful. Wonderful. These are just fun to me. All right, guys, so I'm going to use this algebra, the one we just discussed. I'm going to use this formula, a plus b times a minus b. A minus b times a plus b is a squared minus b squared. Here, a is this, b is this. Okay, I'm using this formula. You can just FOIL. You'll be totally fine. So I'm going to save this here. All right. So I'm going to say the left-hand side is a squared minus b squared. A squared is cosecant minus b squared is 1 square. 1 square is 1. Oh, that's not too bad. What's 1 minus? Look at this. Cosecant square minus 1. The third or the fourth orange formula. Cosecant square minus 1 is cotangent squared theta. I can just go ahead and write it right away. And that is the right-hand side. So I just proved that the left-hand side is equal to the right-hand side. Okay, guys, it's not a bad time to switch. I'll give you a couple of minutes to see if you have any questions on this one. I'll switch and we'll come back. We're not going anywhere, okay? We're going to record the next session. We'll do some more problems. All right, guys, I'm going to head out. I'm going to shut down this session. I'll see you in the next session, all of you. See you soon.